Hey, how you doing, supercoders? Welcome back to a brand new lecture. And in this lecture, we are going to solve this amazing question, digits of a number. And if we are able to code it well, by the end of this video, I will definitely do a coder's dab. Okay. We are in the problem statement given that we are given a number which is stored in the variable n, and then we have to print the digits of the number line wise. So basically, we are getting, let's say, the number 98731. So we have to print in the first line the first digit, in the second line the second digit, and so on till we are printing the last digit. And if we had got the number as 9873, then we had to print first the first digit, then the second, up till the last digit of the number. Okay, this was the basic question. Now I'm going to give you a particular hint, and if you want to solve the question before this, you can. If you want to solve the question after listening the hint, you can. Okay, so if this is the number 98731 and I want that these four digits as the remainder, then what I simply need to do is I need to divide this number by 10,000. Can I say that? Obviously, because this is basic maths and I've got full faith on my super coders that they know this much basic maths. Okay, so the quotient will be 9 and the remainder is 8731. So can I make a simple observation from here that if I want 4 digits in the remainder, then I need to divide the number n by 10 to the power k. Okay, or I can say that if I am talking about the programming, then I need to do the modulus of n by 10 to the power k. The constraint over here is that the number should be having the total digits in the number should be at least equal to or greater than k. Okay, now let's go ahead and I'm just going to write this simple one thing. That let's say initially we have 9873 and I want these three digits as the remainder. According to this is the golden thing. I'm marking it as a star, that if we want k digits in the remainder, then we have to divide the number by 10 to the power k. So if here I want 3 digits in the remainder, then I need to divide the number by 10 to the power 3. That's 1000. So the quotient over here will be 9. So I'm writing the quotient over here. And the remainder will be 873. This remainder becomes the dividend for the next step. Now I want that these two digits in the end become the new remainder. Okay, then I need to divide the number, this complete number, by 10 square because we want two digits in the remainder. So 10 square is 100 and then the quotient becomes 8 and the remainder becomes 73, which becomes the dividend for the next step. Then I want this last digit as the remainder. So I need to divide the number by 10 to the power 1, which is 10. I will get the quotient 7 and the remainder will be 3. Now for the next step, I want 3 as my quotient. Okay. And since there are no digits left in the remainder, can I say that the remainder has 0 digits? And if the digits are 0, what is the divisor? That's 1. Now when I divide 3 by 1, the quotient is 3 and the remainder is 0. Okay. Now before going ahead, let's see one simple thing. Let's observe one simple thing from here. That after each step, at each step, I am dividing the divisor by 10. From here till here, I have divided the divisor by 10. Again, I am dividing 100 by 10. Again, I am dividing 10 by 10, which gives me 1. So over here as well, I will divide 1 by 10. And I will get 0 as my divisor. The divisor for the next step. So can I make an observation? Okay, up till here, you will be now telling me that Mr. Rachel, you are saying that that here the answer will be 0, but according to me, mathematically, the value of 1 divided by 10 should be 0.1. How is it possible? I am saying that initially the value div, I am taking a variable div which is storing the divisor. So initially the divisor is 1000. So this means that the divisor is storing an integral value. Or so if the divisor is storing an integral value, this means that now the variable div is of int type. Now if the variable div is of int type, it says that I am just going to store integer type values. So when it gets 0.1, it tells 0.1 that I am able to store only integer type values. So it discards every digit that's after the decimal. Okay, so that's why I store this 0 inside divisor. Okay, now one more observation is this, that up till here, if I had printed the quotient that I had got at each step, then I would have reached my answer. So basically, the simple thing is that we need to print the quotient. The other observation is that we are stopping once the divisor becomes 0. So let's write the first observation. The first observation is that we need to find the divisor. And the divisor is basically, let's say, we need to find the initial value of divisor. So what is the initial value? If this number had 4 digits, then the initial divisor was 10 to the power 3. So can I say that if the number has got NOD digits, so the initial divisor will be 10 to the power NOD minus 1. Okay. So I can say that the value of initial value of divisor will be 10 to the power NOD minus 1. The second thing is, at each step, I'm going to divide the divisor by 10. This is the second observation that I'm making. The third observation is that I'm going to print the quotient at each step. And also, what's the initial dividend? What is the initial dividend? Initial dividend is basically the value n. Okay. What is the fourth observation that I'm making over here is that at each step, what I'm simply doing is getting the quotient. So what is the quotient? N divided by divisor. I'm going to print this divisor. Then the remainder is n modulus divisor. And this remainder becomes the dividend for the next step. So simply I'm going to code these instructions and reach our solution. Also, we are going to do these steps till the time divisor is greater than 0. You can see over here, we have stopped when the divisor became 0. Let's code this problem up till here. Initially, we wanted the value of number of digits as well. Okay, so I'm taking this initial variable as NOD. I'm putting it to 0. Now, since I don't want the value of n to be changed, I'm taking a new variable temp. And using this variable, I will be finding the number of digits inside temp, or I can say the number of digits inside n. Okay, after each step, I'm going to divide my temp by 10. And at each step, I'm going to increase the value of, oh my god, where the cursor gone? The value of NOD by 1. Okay. Now we have got our NOD. Then I'm going to find the divisor. Now for finding the divisor, I need to use this function. The function is that if I want to find the value of n to the power k, then I simply can write this, that first n and then k. This will return me the value n to the power k, which will be of int type. Okay. So POW 10 NOD minus 1. Because initially the divisor is NOD minus 1 only. Okay, now I'll keep on dividing till the divisor is greater than 0. Also, at each step I'm getting the quotient. So the quotient is number divided by divisor. And okay, I'm writing this code in Java language. I should have changed it into CPP. Okay. Sorry, Python. What I'm doing. Okay, now I'm going to print this quotient. Quotient got printed. In the next step, I'm going to get my remainder. So the remainder is basically modulus div, and then this remainder becomes the dividend for the next step. And we are done with our code. Also, I had to divide at each step. I am reducing my divisor by 10. We are done with our code. Let's code it. Okay. Over here, we are doing a syntactical error because we have not put the symbol. Let's code it again. In line 5 as well. Here, I've used this thing again. Yes, our solution is getting accepted. Our code is getting accepted. Now let's submit it. In this particular complete lecture, just understand this one thing, that if a number, I want k digits in the remainder, then we have to divide the number by 10 to the power k. With this, I end this video. Also, we have to do the dab. Let's do it. This is the coder's dab. We point our hand like this and dab.